Section 2.5, Complex Zeros of Polynomials. Part 1, Introduction to Complex Numbers. The imaginary unit I satisfies the following two properties. 1, I squared equals -1. And 2, if c is a real number with c greater than or equal to 0, then the square root of -c equals the square root of c times I. Note that if x squared plus 1 equals 0, then x squared equals -1, and x is plus or minus the square root of -1, or plus or minus I. We can use the properties of imaginary units to rewrite square root of -4 as an expression of I. So square root of -4, we can also write as the square root of 4 times the square root of -1. The square root of 4 is 2, and the square root of -1 is I. So the square root of -4 equals 2I. A complex number is defined as a plus bi, where a and b are real numbers and I is the imaginary unit. The number a is the real part of the complex number, and the number b is the imaginary part of the complex number. Note that real numbers are a subset of the complex numbers. So every real number is a complex number, but there are some complex numbers that are not real numbers. So let's identify the real part and the imaginary part of each of the following complex numbers. First, 3 plus 7i. The real part is 3, and the imaginary part is 7. What about -3? We could write that as -3 plus 0i, where the real part is -3, and the imaginary part is 0. We have -i, we could write that as 0 minus I, so the real part is 0, and the imaginary part is -1. The conjugate of a complex number a plus bi is a minus bi. If z equals a plus bi is a complex number, the notation for its conjugate looks like this, where we use z with the bar over the z. So if z is a plus bi, z with the bar over it, or the conjugate, is a minus bi. Let's identify the complex conjugate of each of the following complex numbers. 6 minus I, the complex conjugate would be 6 plus I. If we have I, remember we could write that as 0 plus I, so the complex conjugate would be 0 minus I, or just -I. And 3, we could write that as 3 plus 0i, so the complex conjugate would look like 3 minus 0i, which is still 3.